I just sent a request to share my screen, sir.
Sorry?
So I just shared a request to you.
Yeah, I
I just,
allowed you to share.
all right. So this is TCN2501, Python Project Industry Development Group 1. Imagine a cybersecurity framework that combines offensive and defensive techniques in one seamless platform. Our automated cyber attack and defense framework does exactly that, automating penetration testing and vulnerability scanning, while also implementing real-time defensive measures, from performing reconnaissance with port scanners and vulnerability checks to executing attacks like SSH brute forcing and SQL injection. It covers the full spectrum of cyber threats. And on the defensive side, it actually actively detects intrusion and applies countermeasures to block attacks. This project is a comprehensive toolset for not just simulating cyber threats, but also defending against them, providing organizations with a powerful way to stay ahead of attackers. Automated cyber attack and defense framework, offensive and defensive security. This is presented by Ainde Taiwo, which is yours truly, Achoi Chimchimeremeze, Taiwo Michael, and Awudoyin Elijah.
Introduction and problem statements. Importance of offensive and defensive security testing. Cybersecurity threats are constantly evolving, and it is crucial for security professionals to stay ahead of attackers. A well-rounded security framework can automate penetration testing techniques and defensive measures to ensure proactive defense. Offensive testing, for example, exploitation, and defensive security like intrusion detection are both critical to understand and mitigate real-world attacks. Overview of cybersecurity threats addressed. Reconnaissance and enumeration, identifying open ports, services, and potential vulnerabilities. Exploitation and credential attacks, exploiting weaknesses in services, brute forcing SSH, and sniffing sensitive traffic. Post-exploitation and command and control C2, gaining control of compromised systems and executing commands. Web application attacks, SQL injection, command injection, and more. Defensive measures, intrusion detection system, IDS, and defensive log analyzers.
So project objectives and scope. Key functionalities of the framework: reconnaissance, automate port scanning, then vulnerability scanning, then exploitation, automate brute force attacks, ARP spoofing, then keylogging. Then post-exploitation, remove command and control server, C2, and shell interaction. Then web security, SQL injection, web exploits, and cross-origin resource sharing, CORS exploits. Then defensive measures, implement IDS, then countermeasures for each attack. In cybersecurity testing, integrate techniques, mitigate attacks. So what the project aims to achieve: develop a fully functional cybersecurity testing suite with offensive and defensive capabilities, then integrate various cybersecurity techniques into a cohesive framework, then help organizations understand and mitigate real-world attacks.
Okay, this slide tells about the technical architecture of this particular project. First of all, reconnaissance. We start with this using port scanners and vulnerability scanners to identify weaknesses. Then we move to exploitation, in which we use SSH brute force, ARP spoofing, and keylogging to gain access. Post-exploitation establishes the command and control server, while defensive security uses IDS, which is the intrusion detection system, and log analyzers to detect and respond.
Okay. Phase 1, target reconnaissance and enumeration. Demo 1, port scanner and vulnerability scanner. The port scanner. Developed using Python to perform multi-threaded scanning of a target machine to identify open ports and running services. It uses sockets and threading libraries for efficient scanning. Vulnerability scanner integrates with external vulnerability databases like CVE to check for known vulnerabilities in discovered services. So here is a picture of the code, which I'm going to explain now. So this is a Python script that performs a multi-threaded port scan on a given IP address, on a given IP address, and attempts to identify potential vulnerabilities based on the services running on the open ports. So as you can see, this is the code here, and when run, it's showing me the IP address to scan, the starting port number, the ending port number, and the number of threads. So then the port scanner, multi-threaded scanning to identify open ports, uses socket and threading libraries. Then for the vulnerability scanner, integrates with external vulnerability databases, check for known vulnerabilities. So the outcome, the framework can automate reconnaissance and provide insights into potential vulnerabilities that can be exploited.
Sorry, is that all?
For my face, yes.
Exploitation and credential attacks. SSH brute force and keylogger. SSH brute force attacks automate dictionary-based brute force attacks on SSH services to test the strength of credentials using Python's parameter library to interact with SSH services. So I will demonstrate it now for the SSH brute force attack. So first, I'm going to be using my PC as the test subject here. So the first thing I'm going to do is I'm going to launch my SSH server. So then I come here and I run the script. So first, it needs the IP address. So I'll get my IP address. My PC username. So it's running through a dictionary of passwords. And it has found the password.
Sorry, can you demonstrate this one more time? I was
Okay,
trying to actually impute a score when.
So the first thing I did was I started my SSH service using the sudo service SSH restart command. And then I came here and then I ran the script with roots. And then here I'll grab my IP address since I'm using my PC as a test subject here. And the username.
Can you explain clearly the content of the script, code for code? Then we now actually go back to the guy who actually did his own. You did not demonstrate that first part of your script. You just summarize. Now it's a code presentation, so it's not a project. It's a code presentation. So you tell us code for code what you did and explain right through how you got to where you are. So code for code, explain.
Okay, sir.
Okay.
No, let
So-
I will finish first, then we'll come back to you.
So here we import all the modules that we need, which are Paramiko, Scapy, OS, Time, and Scapy all. And with Scapy all, we import sniff too. So the first function, load passwords. This function is used to load passwords from a particular file. So the first thing we do is we read a file containing potential passwords for brute force attacks.
Sorry, I didn't see you define a file path. That's actually why. Where's the file path? How do you define the file path on the code? Because it's actually where's the file path? I didn't see the input of the file path.
In the code.
That's the only thing I was missing. I didn't see the input of the file path.
Okay, the input of the file path.
How do you define the file path? Because you said define load password file path. How do you get this file path? How do you
Since I'm using my PC, I hard coded the file path into the
script?
Yes, sir.
Okay, is that a professional act? Let me see where you did that. What line of the code is telling us that?
This is it, sir. Here, this is the parameter.
Okay,
for
you
this
define
function.
the password of
Yes.
TXT. Okay, all right, but
Yes.
that's actually not a professional. There should be the flexibility of you actually imputing password files when you are actually doing a commercial script. All right, you don't so that everybody can come with his own password list and actually run the script. So you can continue.
I understand, sir. So it returns a list of passwords. So here, this we have to try and
please
accept.
go back to the modules. Go back to the modules. Tell us the use of each of those modules in the script. Paramiko, what's Paramiko doing? What's Skippy.all as Skippy? What's OS doing? What's Time doing? What's Sniff doing? Because that means if you're sniffing, that means you have two scripts in one. So one is doing SSH because those Skippy.all as Skippy and Skippy.all import sniff. They are two different, they perform different job than actually just brute forcing. They sniff for password when you are actually using a web page. So let me see what are those scripts doing in each of those modules? What are they doing in your script?
Okay, each of the modules. Okay, so the first one, which is Paramiko, it's a library that provides secure remote access to servers and other network devices using SSH.
Okay, all right, that's fine. Skippy.all as Skippy.
Basically, Scapy is used to send and receive packets. Then we have
What sniff? Skippy.all as Skippy is different from Skippy.all as sniff. They are two different models. Why did you actually use Skippy.all as sniff?
so basically, because I wanted to capture and analyze the network traffic. That's why I use sniff. And Scapy.sniff is like a function that allows you to capture network packets and store them like a list for the analysis.
Okay, let's run through the functions and the code. Start from it. I can see it define load password file path.
Yes. So the first code, it reads a file containing potential passwords for brute force attacks, returning a list of passwords. So we have to try and accept here. So if for some reason the file cannot be found, we have a way of handling that error. And this is it. It's going to show error, password file not found. So the next function, the next function is used to perform SSH brute force attacks. So attempts to brute force an attack an SSH login using the dictionary attack and prompt the user for a target IP and the username, just like I did in the code. Just like I did in the code. It's going to prompt the user for the IP address and the target username. And here, this is why I said that hard-coded the password list, but you said it's not professional, so I'll make it better one next time. So we have a condition said if not password list, print error, no passwords loaded, check your file. But if password, for password in list, it's going to try, and it's going to use the, we are going to use the try and accept here. So here it's going to print out try and password. And then for password, inside the password list, it's going to try them. This SSH.connect is going to link the target IP to the username and also the password. And we have a timeout, meaning that if we don't get any response in 5 seconds, the code basically terminates. Print here is going to, when password is found, it's going to print success, password found, and it's going to show us the password of what we are trying to get.
Sorry. That XSH.connect, can you go back to it? As you can see, it's connecting with target IP, it's connecting with username, it's connecting with password, but there's no port there. Did you specify the port?
No, sir.
Okay.
Because we're running SSH, so I assume that since SSH is port 22.
No, you don't assume. It's connecting. Yeah, it has to connect with the port. Or is there any way you define it for 22? Just go ahead. Just go ahead.
Okay. So if by chance SSH, if by chance the password is not correct, it print out failed incorrect password. And if by chance SSH is not running, it will print out SSH connection failed. Check if SSH service is running. So we have a function. So we'll move on to the next part of the.
So from what I can see in that script, can you bring back the script? There are two scripts in one. There is an SSH brute forcer and there is a packet sniffer. There are two
Yes,
scripts in one.
there's actually 3, sir.
Okay, let me see, but you are just jumping the script.
Okay.
Let me see. Okay, you want to take that one first, that SSH first.
Yes, sir. Then I move on to the next.
Display the SSH again. Let me see.
Okay. So here, since I said I'm using my PC as the target, so I will get my IP address from here. Then, because I already initially ran SSH, I already started my SSH service. So it's the username. Which defines the password.
So it says password found, but okay, you are the one who keyboard interrupted.
Yes, I'm the one who because it was just going to keep on going.
Okay. So it doesn't stop after 5 seconds. You don't have a flag for it to exit normally once you found the password.
It's not, it automatically exits that particular code.
Okay,
let's
see it exit automatically. Now, what you should know is this: the code does not really need to be in a perfect state. After now, you can go and enhance your code and make it more elaborate. You get it? The code does not need to be in a perfect state. After now, you can go and enhance your code and make it more elaborate.
Okay, sir. It just moves on to the next function after the password is found.
Okay, all right.
This is the packet.
Okay, all right, that's fine. That's fine. So are we done with this phase?
Not yet, sir.
Okay.
So so we have the next, which is the packet sniffer. The packet sniffer in the script is responsible for monitoring and capturing network packets on a specified interface. Here's what it does. It uses Skippy sniff function to listen for network traffic, captures and displays packet summaries in real time, runs a specified network interface, which is Etho, does not store packets. It only displays them live, and stops when the user inputs it manually control C. So it stops when I use the
Sorry,
keyboard.
in your whole framework of code, what role is this sniffer playing? You've been able to actually identify the port, you scan the port, you send the port, now you brute force SSH. Now the next thing you want to actually sniff, what role? How are you connected? Like, I am an attack, I'm a penetration tester, I'm trying to use this tool. Can you actually show me what benefits are this particular in the sequence? Now I know open ports. Now, the next thing is, okay, from the open port, I want to actually take advantage of some of the open ports. So are you assuming that port 22 is already open from the device? So you want to exploit port 22 to actually see what the vulnerabilities, or you can actually get the password to see what security they have around port 22, because you're not reporting very well. Now, as you are presenting, you should be reporting yourself as a penetration tester using the tool, or as a cybersecurity. So you're actually telling people, in case you want to actually do this, this is how you use this tool to test for this. This is how you use this tool. Now, what you just demonstrated, that you can use the tool with a set of password to actually do what? Test for what? Do a password SSH brute forcing. Are you with me?
I'm listening, sir.
Good. You are not defending any lab. You are presenting a project you have done, and you are trying to build it to commercial use. Do you get it clearly? Good. So let your tone go in that direction.
Okay. So basically, my packet sniffer.
Just 1 minute. Let me just. You can go on.
So basically, I'll just say a few uses of my packet sniffer. Can be used for network troubleshooting. Can be used to diagnose network issues such as connectivity problems, slow network performance, and packet loss too. Can also be used for network security monitoring. Monitor network traffic for signs of unauthorized access or other security threats. And
A packet sniffer.
yes, sir.
What standard industry tool do you know? Do you know what Wireshark does?
We can use Wireshark.
Okay, good. Now, so what features do you have on this particular tool that can actually do all those? So can you demonstrate what you're doing? I'm seeing UDP, I'm seeing.
Okay, sir. So let me demonstrate how it works. So I'll share my Kali Linux screen now. So basically, when I run the code and I put the IP address, username, after this, we can test the packet sniffer. Now, if I type in this command, it starts capturing the packets. You have query and answer, asking for who owns and who owns. So now if I connect But I don't think I have any other computers here. If I connect another device, trying to launch another virtual machine so that we can see more packets being captured. So it's there to capture.
So can you go into the codes of what this script is, function for function? Because what I'm saying is actually not a sniffer, it's a keylogger capturing different keys of what you're doing. Okay, let me see what the sniffer
Maybe
does.
on the slides or on my screen.
Okay, let me see what the capture does. Let me see what the capture does. The code you actually imputed, you define the
Okay,
interface.
good.
I'm
Okay.
seeing where you defined an interface. Okay.
So here the function, this function is used to restore the ARP tables.
No, I think there's a misconception
The
somewhere.
packet sniffer, this is it right here, sir. So
No,
since
because
the interface,
wait. What are you showing me? Is it the sniff? Because the one before that is actually not doing what you are. It's not the one doing this.
yes, it's not the one. It's not, this is the packet sniffer using the interface of my own PC, which is Etho.
Okay.
So it captures and displays network packets on the specified interface. And we have talked about sniff before.
Okay.
So right now, if I ping a random website, it's going to capture every single packet, echo request, and reply. We even have some ARP here, and that's for the devices that are just connected to my network. So this is how it works, captures data packets.
Okay. Your keyboard interrupted again. Okay, all right, that's fine. Okay, is that all you've been able
No,
to
sir.
come? Okay, all right. Let me see the other
As
part.
for the keylogger, the interface I want to, normally I would have used it on the GUI, but it doesn't work. Even importing the module that allows it to work, it doesn't allow me to import. So I tried to import it on a virtual environment. I managed to import it, but I still could not, it still couldn't work. So I had to use it on a TTY interface. So, and I'm saying this ahead of time because there's a huge possibility that TTY interface is going to crash. And it's been doing that not only for me, for the others too. Should I go ahead with this?
Go ahead. Let's see what you have.
So this is the interface here. So I have to do is I need to launch the code from inside here. Because sometimes it doesn't capture key. Okay, finally let me in. So here I'm going to change to my desktop directory. I'm going to run the code. So keyboard interrupt this. And I can't type in anything anymore.
Okay, all right, that's fine. Is that all you have to show us?
Yes, sir.
Okay, all right. Taiwo Michael, can you show us your script?
Okay, sir. So um so I'll be explaining the code from the import socket. So the import socket is a built-in Python function that allows to create network sockets and communicate over the network. While the import threading, it basically allows us to run multiple tasks concurrently. So then I predefined common vulnerabilities for certain services, like the known vulnerabilities. Then I listed everything here. Then I started with the
Okay,
port scanner.
sorry. The vulnerabilities, you actually predefine them, not like it connects to a particular server somewhere to actually
Yes, sir.
get the
Yes, sir.
vulnerabilities.
Because
Okay, that's fine.
so I started with the port scanner. The port scanner function identifies open ports and tries to get the service. So I defined the scan port, the IP, the start port, the end port, the open port, then log. Then here is a for loop for port in range. It's giving it a range for the starting port to the ending port. Then try sock equals to socket or socket. Then sock timeout. That's 1 second. So let me scroll down so you can see the later part of the code. So if the result equals to sock.connect, then the IP, then the port. If the result is equals to 0, then I told it it's going to get service information from the open port. Service equals to get underscore service underscore banner, then the IP and the port. So here is with lock to ensure the thread safe access to open ports. Then open the port to append the port and the service. Then close. Except sock.errors, then it's going to print error scanning ports if there's an error that comes up while it's doing all those functions. Then the function to try to get the banner of a service running on the port, whether HTTP version or SSH version. Here is they have get service banner, the IP and port. So yeah, I'm using the try and except. It's going to try sock, then socket .afinet, then sock stream, then set timeout 1 second, then sock.connect IP port. Then it's going to send the head and the HTTP. That's for the HTTP service. Banner equals to sock rev to decode, then sock.close. Then here is an if statement. If banner, return banner.split, then into a new line, this R slash N. Then extract the HTTP header. Then it's going to return service detected, except there's an error, socket error, then it's going to return unknown service. So let me scroll down to explain the later part. So we move to the multi-threaded port scanner function. As I said earlier, it's used to perform multiple tasks concurrently. So I defined multiple threaded scan ports, the IP, the start port, the end port, and the number of threads. So you input the number of threads, the open ports. It's going to give me the number of threads and the open ports. Then lock equals to threading.lock. To lock for thread safe access to open ports. Then the ports per thread is end port to start port plus 1. Then the number of threads. Then this is a for loop here. For I in range, number of threads. I'm going to give it the number of threads. Then start equals to start port plus I, then port per thread. Then end equals to start port I plus I, then port per thread. Then if I equals to non-thread, I'm going to ensure the last thread covers the remaining ports. Then end equals to end ports. I'm basically going to end the ports there. Then thread equals to threading.thread, the target, scan ports, then the IP, start ports, the end ports, then the open ports, then lock. Then threads to append, I'll append the thread, then thread to start. Going to start the task. So for threading threads, it's going to just join the thread, then return open ports. It's going to give me back the open ports between the ports I inputted, the starting port and the ending port. It's going to give me the open ports between that. Then the function to query common vulnerabilities based on the service without API. Then this is a def vulnerability scanner service. Then we're going to look up vulnerabilities based on the service name from known vulnerabilities, like I listed above. So if service in known vulnerabilities, print F vulnerabilities found for service, then service. Then for vulnerability in known vulnerabilities, this is a for loop. In an if else statement, but a for loop is also inside. Then print F von CVE, then von description. Else print F known vulnerabilities for service. Then I called the main, define the main function here. Then this is it here, sorry. Def main IP equals to input, enter the IP address to scan. Then int input, enter the starting port number, then I'll input that. then int input enter the ending port number, then I input that. Then int input enter the number of threads, then I'm going to input that. Then it's going to perform the port scanning here. Then the open port equals to multi-threaded scan port, so that I can perform multiple tasks. IP start port, end port, then the number of threads. Then if open port, print F open port and services on IP, on the IP address actually inputted to start the task. Then for port service in open port, print F port, then service. Then it's going to query vulnerabilities for the service, then vulnerability scanner, then service. Then else, print F no open port found on the IP in between. So if there's actually a port open and there's a service, it's going to print out the open port and services. Unless it's going to print out no open port found on IP within the starting port number and the ending port number we actually gave to it. Then this is the last part that I just called back the main function. So I'm going to run the code now so that we can see how it actually works. So I have an IP address here, 142.250.200.142. It is going to ask me for the starting port number. I'll just give it 1. Ending port number 80. Then number of threads 4. When I press enter, it's trying to look for the open ports between this. It's going to take like few seconds before I actually get the results. So as you can see, this is the results here. It has actually found open ports and services on this IP address, which is port 21, but it can't identify the service. So it gave me unknown services, but it actually gave me the ports that was open. Then the vulnerabilities found for service is unknown service because it's actually not connected to a server, as I predefined the services and the servers up. So there's no server it's connected to. That's why it's actually giving me unknown service. Then the CVE, example vulnerability for unknown services, port 80, then HTTP/1.1.200. Okay. Then vulnerabilities found for services is this HTTP 1.1.200. Okay. Then the CVE 2021-34527. Windows prints Spooler remote code execution vulnerability, prints nightmare. Then CVE 2020-14882. Oracle Web Logic remote code execution. So, that is all. So let me move back into the slides and just say what. So as you can see, I already explained the results here. Though this framework can automate reconnaissance and provide insights into potential vulnerabilities. Then I will run back through the port scanner. It uses multiple threaded scanning to identify open ports, then uses sockets and threading libraries. Then the vulnerability scanner integrates with external vulnerabilities, then checks for known vulnerabilities. Yes, sir. That's all for my face, sir.
The group 1, do you have any other presentation, or somebody wants to wrap up this whole presentation? Or is that all the code you wrote?
Sir.
Because it stopped. We have about 5 phases. We have
Yes, sir. We still have left for the remaining phases.
Sorry?
So we still have code left for the remaining phases, sir.
Okay, good. Let's move on. Let's move on to the remaining phases. I know the only thing I said you should actually skip is SQL injection.
Yes,
right?
Sir. And that's the only thing we skipped. Yes, sir. So we still have 4 phases.
Let's see the post-exploitation and command and control center.
Yes, sir.
All right. So phase 3, post-exploitation and command and control center. Now, the SQL injection, it automates the SQL injection attack to extract sensitive data from vulnerable databases and demonstrates how poorly secured web applications can be exploited, exploiting secure authentication mechanisms or input validation flows to execute commands on the web server. So let's go to Kali, see the code. So there are 2 codes here, the client and the server. So this script sets up a command and control C2 communication between a server and a client over an SSL/TLS encrypted connection. The server sends shell commands to the client, which executes them and returns the output. So starting with the emojis that we have here, we have for the server code, import sockets and import SSL. The import socket imports the socket module, which allows the creation of network connections, while the import SSL imports the SSL module to enable secure TLS/SSL communication over the sockets. I'm moving on to the start server function. So the start server equals to host equals to 0.0.0.0 port 99 function. What that does, it defines a function, start server, that binds 0.0.0.0 and listens on all available network interfaces, and also listens for incoming connections on port 9999. So we start first with create and bind the server sockets with the server equals to sockets.sockets line. So what that line does, socket.sockets bracket socket.af inet socket.sockstream. It creates a TCP IP socket. And then the server.bind host and port. It binds the sockets to the specified host and port, like I said, 0.0.0 and 9.9.9. While the server.listen 5, it puts the socket into listening mode, queued connections. Then it prints F listening on port, host port. It prints a message indicating that the server is running. Next we have the setting up of the SSL and /TLS encryption with the context is equals to SSL.create default context line. So what that line does, it creates an SSL context that requires client authentication. And then the context load certificates cert file is equals to cert.perm key file. So what that does is that it loads the server certificates and private key for encryption. Then the wrap socket with SSL. The secure server equals the context of wrap. What that does is that it wraps the server socket with SSL/TLS encryption. Now moving on to the while true line. What that does is that it accepts and handles client connections. So the secure_server accepts, what it does is that it waits for and accepts incoming client connection. And then it prints F connection from ADDR index 0, ADDR index 1. What it does is that it logs the client's IP and the port. And then the handle_client sockets passes the client sockets to handle the clients. Passes the client socket to handle_client brackets. Now moving on to the define handle client function. So what that does is that it waits for the user to input shell commands and sends it as a command to the client. Then it encodes the command into bytes with the bracket send command dot encode before sending. Now to receive and display the client's response, we use the client_socket.recv 8192.decode. It receives the command output from the client and decodes it. Then it logs the response. Now for the if command here, what it does is that if not response prints no response from client break. So what that does is that if no response is received, it prints a message and then breaks with closing the connection. And then for the if name is supposed to main, start server. That's where we ensure the start server runs only when the script is executed direct and not imported. Now moving on to the client. The client codes. Here we have the import socket and import SSL, like I already explained in the server code, and then we have import subprocess. So what does the subprocess module do? It enables execution of system commands. I will start with the first function, which is the start client host equals localhost.
Sorry, just 1 minute. I'm saying client. Okay, you are now on client.py because I saw server.py. I saw
client.
Yeah. All right, that's fine. You can go ahead. I hope you're going to demonstrate this.
Yes, sir. Yes, I will. So now, the first function, what it does is that it defines the start client that connects to the server on the port 9999. And then we create the SSL context, which is context equals the SSL that creates the default context, which creates a secure client-side SSL context, and then disables SSL certificate verification to allow self-assigned.
Sorry, just 1 minute. So that we don't run out of battery. Let me turn on the gen. I will pause the video.
All right. So moving on from the connect to the server using SSL. So the secure_client sockets, what it does is that it wraps its sockets with SSL. and attempts to connect to the server and logs a successful connection. Then, for the while condition, it receives and decodes a command from the server. And then, if the command is exit, the client then disconnects. I'm moving on to the execute command on the client machine. What that does is that for the subprocess.run, it runs the command, the output, it runs the command using subprocess.run and then captures both the std out and the stder output. Then the secure underscore client underscore socket dot send bracket response. What that does is that it sends the command out back to the server. Then the secure underscore client underscore sockets dot close. It closes the client sockets when it ends. So now we now use the if name equals to main to call back the function, then run the client's code. So first off, let's begin with the server code and run that here. So set up server, we run the code using sudo. So now it's listening on 0.0.0.0.9999 and then asking to enter the PEM passphrase. So you might be wondering, what does this PEM passphrase have to do with this code? So for the role of the PEM in the code, it is an SSL certificate as a servlet-cert.pem. This is the public key certificate that authenticates the server and helps encrypt the communication to prevent detection by network, while the server-key.pem is a private key associated with the certificate. It is used to establish a secure connection with the client. So now putting in my passphrase, my PEM passphrase, which is this. So now the server is up and listening. So let's run the client code from the terminal. So now to run the client code, we do client software. So now it has connected securely to the server. Let's go back and see that connection from this is the IP address and then this is the port. Now let's run the shell command because we're using my system as the vulnerable system. Let's run shell commands. Run ls. So we can access the files of the clients that's connected to the server. Shell commands. You can also run as you can see, the server and the client is working.
Can you change directory?
Yes.
Yeah, change directory. Let me see. ls. Can you print working directory? Print
Yeah, I
working
already did that. I already did that CT.
Sorry? Yeah,
CT.
you are in home Kali. Print working directory from where you are.
Provide reason now. I mean, start it again.
You're not getting response. Okay, all right, that's fine. That's fine. That's all the demonstration. At least you just need some little enhancement on the code. You can do a less. Now let's move to that should be. You see, I know the limitation of most of those codes because I've done all of them before. Good. Now we are skipping SQL injection and command injection bypass. Now we're moving to that's 5, right?
Yes, sir.
Yes,
Okay,
sir.
let's move to 5. Let's move to 5. Let's move to 5. So defensive security measures. So who is taking 5? Okay, all right, that's fine.
Okay, here is phase 5, which says defensive security measures. Demo 5, IDS, which is intrusion detection system and countermeasures implementation. So first of all, we have the IDS, the intrusion detection system. Its purpose is to detect malicious activities like port scanning, brute force attacks, and unexpected network traffic patterns. How it works. It monitors the system logs and the network traffic for suspicious patterns. It alerts the system administrator about any detected malicious activities, be it unusual connection attempts, multiple failed login attempts. Technologies used. It utilizes tools and libraries like OS, PSUTU, ARI, default date time modules, all those for monitoring and detecting malicious traffic. Countermeasures used. We have automated response. Once an attack is detected, the framework can implement automated countermeasures to mitigate the attack. An example is blocking IP addresses involved in brute force or scanning attempts. We'll see that shortly, while enabling firewall rules to restrict incoming traffic from suspicious sources. Also implementing anti-keylogger measures that block keylogging programs from running on the client. Okay, let me share my Kali. Okay, my Kali should be displayed right now. So this, okay, first of all, we import OS, which provides operating system related functionality. Then we import PSUTO, which is the library for retrieving system and processing information. We import RE, which allows us to work with regular expressions for pattern matching in text. We then from collections import default dict, which is a dictionary subclass that provides a default value for missing keys. While from datetime, we import datetime, which handles date and time operations, which will be used down here for login timestamps. Now, the threshold, we defined this both threshold for detecting suspicious activity. We said scanning threshold is equal to 10, which means maximum allowed connection from the same IP before flagging as scanning. Then brute force threshold, which is equal to 5, which is maximum failed login attempts before flagging as brute force attack. Then this is the path to the off.log file. My personal laptop off.log file does not have so many failed attempts and everything. So I used the one that we got earlier in the classes, which is off.log.txt. Then I say patterns for log analysis. We said patterns is equals to failed login is equals to array.compile failed login, which defines regular expressions to match specific log entries. So we define this in order to match failed login inside the log file. Then we say port scan is equals to compile port scan detected, then malware is equals to malware detected. Then our first function, which is the log event. So it says this logs a message with a timestamp. So we see timestamp after importing it using the timestamp module. Timestamp is equals to datetime.now.strf time. Then I must get the time, date and time right now. Then transform it into year, month, day, hours, minutes, and seconds, which is what is here. Then print it, print F, timestamp, then the message. Then this is the next function to read logs from an off.log file. So we say read off log. Then we come here, we say which reads the content of the off.log file. Then we have a potential try, and accept error to find potential errors. So we say try with open off log path, read as log file, return log the file the read lines, log file the read lines, sorry. Then we say except if you find out that file not found, print this error. Else, if is permission error, print this. If it's exception as E, print this and return an empty list. So we say function to detect scanning and brute force attacks, detect intrusion of underscore log lines, Then we say this detects scanning and brute force attacks based on the log line. So we say IP attempt is equals to default dict, which we have imported, then int, which tracks the number of attempts by IP. While failed logins is equals to default dict as an integer, tracks failed login attempts by IP. So we say try for line in off log lines. If failed login in line, match, then find this. So this is to find the IP address. As you can see, there's a dot separating it 1, 2, and 3 here. So this is if it matches this, search for this particular string. If it matches in field login, then this is to extract the IP address. Then if match, if there's an IP address, add it to this group IP, then add one to field logins IP. So if we get the IP address from the field of login, in which field of login is a line, then add one to field.logins as IP. So else, this is to check for other connections and extract IP addresses. So look for IP address, and if match, add one to group, then IP attempts, add one to it. And this flags with excessive connection attempts. So say for IP attempts in IP underscore attempt or items, if attempts is greater than the scanning threshold, which we've already defined up there, which is 5. So log attempt, scanning detected from this. So if the attempts that were found in IP underscore attempt that we've added 1 to is greater than the scanning threshold, print this alert, scanning detected from IP, then print the IP. Then if the attempt is greater than the scanning threshold, block the IP right here, which is the countermeasures that we used. Block IP immediately. Then we now see for IP, fails in failed logins, if fails are greater than the brute force threshold, if fails are greater than the brute force threshold, like if number of fails is greater than the one already assigned up there, print alert, brute force attack detected from IP, then block IP immediately, which is the countermeasure that we use. Then the exception error for
Let me see. Did you define what block IP is? Okay, that's the function for block IP. Because
yes,
I'm
sir, right
seeing
below
you
you.
use block IP. You have not defined what block IP. Okay, all right, that's fine.
Yes, sir. So we say unexpected error in text intrusion. If there's an error, then this is the block IP, which is the countermeasure we're going to use. So this is the function to block IP addresses using a firewall command. It blocks the specified IP address using IP tables. So this is the command right here. The firewall rule to block the IP. Then we now execute the command using os.system command. Then log event blocked IP equals to the IP that was blocked. Then this is a function to analyze logs for specific incidents. Analyze logs, log underscore lines. It analyzes logs for patterns of suspicious activity. So we say for line in log underscore lines, for incident pattern in patterns or items. If pattern search line, which is searching for a match in the long line, detected incident, print detected incident in line or strip. So print the particular incidents that we find and print what is in the line. So function to log keystrokes using show key. So this is the key logger. So it logs keystrokes from the terminal using the show key command. So we say log events, print this, keylogger running in teletype terminal. Then I say try with open keylog.txt.a while true, capture key presses using the show key -k command. So while true, we say key is equals to os.open, then we use this command, the read. So if key.strip, log file writes the key. So writes the key press into this log file. Then after that, we ensure that the log file is updated immediately using the flush. So after all has been satisfied, we now print log key press logged and print what the key that was used, which prints key to the terminal. Then we have our exception, except keyboard interrupt, keylogger stored by user, exception as E, unexpected error. So this is the main function to run all the components of defined above. So we say this is the main entry point for the intrusion detection system. It executes the log analysis, the intrusion detector, detection, and the keylogger. So we see log events starting intrusion detection, which is printed, then reading logs from alt.log, then it reads the log. And if alt log lines detects intrusion right away. So if auth.log unauthorized is found, carry out this function detect intrusion, which detects brute force and scanning attacks. Then after which it now analyzes the logs of that auth.log lines. So we now say after all those have been satisfied, it now runs the keylogger, which now calls the keylogger function. Then it will run the main script. So I'll run this. So as we can see, it has begun intrusion detection right away. So let's see the index. So it said with the timestamp right beside it. Sorry.
Okay. All right. That's fine. What can you deduce from this? No, this you are saying intrusion detection. This
Yes, sir.
particular data is not a live data. I hope you get
Yes,
it.
sir.
You are actually taking a log file that is not live. So when you talk about intrusion detection, it is as the person is actually entering. It's okay. What you're doing is okay. You will have time
Yes.
to repeat this 4 or 5 times before you go back to university. So at every point in time you come back after taking more lectures, you will enhance the script. They call it script enhancement. So you add more features to it. So you are working currently based on your knowledge. You are deploying based on your knowledge capability. So as you're upgrading your knowledge capability, you are implementing more features, advanced features to make it so. That's actually building your. So can we round this up?
Okay, sir.
So who is rounding the presentation up?
Okay, I will take that.
Okay, all right, that's fine.
So we'll run through our key findings and challenges. So challenges I faced while trying to get our intrusion detection system were as follows. So first of all, the keylogger gave a lot of issues. I tried going through the TTY, which is a teletype terminal, to go and get the figures. So I tried going there, I keylogged, I typed it, but it was not displaying on the keylog.txt file. So that is one main challenge I faced. And the key finding I made was that integration is crucial and automation helps simulate attacks. I mean, it doesn't have to be done manually. Once it has been set and the code has been written, it automatically detects and simulates attacks, which is very important. And it finds out the failed attempts, malware detected, and so forth.
Okay, just hold on 1 minute. Let me show you what a commercial script looks like. Now, so that you guys will have it in mind the next time, because you still be coming back after this. Now, this is a script called reconhex. Now, what it simply does, these are all the options of what it can do. So I was expecting you have an interface. Are you saying like this that displays all what you can do? Enter your choice. If I enter one, are you getting? If I enter one, you see that you are displaying the codes differently. Now that's just explanation. The whole code should actually be in one simple tool. It will tell me enter host name. If I say Kali, it is wrong. Who is Kali? So if I run the script again, it's a bad script. I say one. If I enter host name, if I say HTTPS, it's backward slash, oh, possibly HTTPS, sorry, google.com, invalid error key. Now, I'm just trying to tell you we did project submission recently. So we're looking at different different gaps on the tools submitted. Somebody did something like this. So you see that the whole idea is to actually, if I say HTTPS, I'm just trying to test. I put google.com. This is a standard. So let's see if it's going to be, you see, it's still telling you error. Now let's look at let's do hall 14. So let's run the script and try to run all the options. So directions, what's name? Let's say Candy. So you see, it's doing all at once. So you see, this looks more like the finishing looks more like an industry tool. Yes or no? Even if it has some bugs, do you get it clearly? Now, if you come back into it and see what's actually doing that stuff. So if you do batch. So while I told you guys to go that is so that you can actually do research, are you saying this is what's doing all the display? Being a bad script, it should give you understand. So when you are running something with multiple options, you develop it in a way where these are the different stuffs. You develop it in a way, this is where it handles the case. I'm sure you know case. It handles input who is. So, but the main first part is actually just, and this is the ending of the script. You see that there's barely nothing so much inside the script in terms of coding than this part where you actually make it very attractive and usable. Are you getting it? This should be Figlet. So this is where you actually, so the next time you are coming, you do something like this and actually encrypt your name on it. So before you do it 4 different times, you should have been sure of a product ready for the market. Did you get it? Now, that's that for presentation control X. Now, what you did is just currently based on your knowledge. Like I said, the last time we actually had this, we actually did what? We wrote out the code without telling the students to come. And so when they came back, you guys all tried at your capacity. But when you've done the next, by the time you finish this next NR, I believe you have more. By the time you finish penetration testing, you have a full-fledged, then this your group, you maintain it. You do penetration testing, you do tools, you do other penetration testing, and you do tools. So there is equal participation and teamwork. That's spot on. Now, implementation of all modules. That's okay. Efficient coding and error handling. That guy, I think you guys are struggling. You see the one doing server and client. It's because I've done that before. I know the limitations in some of those codes. That's why I told you to actually navigate. I know that you did not code it to the point where you gave it option to navigate to other directory. Now, if you try to exit, it will not exit. That code you wrote will not exit from the server. So as you start building, you start actually understanding what it takes to actually, but all this is building confidence in what you're doing. So do you have a question for me? So that's your score. So
No,
I'm sure you now actually see what an industry tool looks like. So that is next time you're developing one, everything should be in one shop. All the code should be in one shop. You get it? So you can dictate, and by the time you've done penetration testing, you would have seen different tools. Everything is in one shop, not different codes, but this is a very good start. So if you guys don't have a question for me, you are the only one talking. So and in that time, do you have a question for me? You are talking something about, okay, well, I don't know how to, you see, I might not know all the best way to actually succeed, but the fastest way to failure is to try to please everybody. Be yourself. As some people say, manners or you don't have manners or this one. Be yourself, build what you can build, ensure you keep adding to your capability every day. You understand? You see that what you have that can actually dictate the future or create a future is capability. So doing something like this and building capability in it, but I'm sure by the time you get back to university, this is just 3 months. You still have 3 more months. I hope you know. Good.
yes, sir.
So by the time you're going back to school, I'm sure you'll be fully baked. And anybody talking to you will know, yes, you've passed through a training. So let's actually stop here so that the second team can come in.
Okay, sir.
Good morning, sir. So can you see my screen?
I can see your screen.
Okay. Again, good morning, sir. We are excited to present our security automation system, which is a powerful tool designed to enhance network security and automate threat detection. Our team, Odubanjo Boluwatife, Okoye Sunday, and myself, Attorney Chidera, have created the solution to help organizations proactively defend against cyber threats. Firstly, I'm going to talk about the introduction and the problem statements. So we included automated security, threat detection, and breach prevention. So we automate network security, detect threats in real time, and prevent cyber attacks. And also we enhance overall security and prevent breaches. So what exactly is this system that we created? It is basically an automated security system for monitoring networks, and detecting threats and enforcing security policies. And why is it important? It reduces manual work, improves efficiency, and enhances security response. Now we're going to talk about the objectives and the project objectives and the scope. Firstly, we divided it into 4 phases. The first one was network monitoring and intrusion detection, which is basically identifying unauthorized access attempts and suspicious network activities. Secondly is log analysis and threat hunting, which is basically detecting anomalies and patterns with system logs and indicate compromise. Thirdly is incident response and automated defense, which executes countermeasures to block malicious IPs and mitigate active threats. And then lastly is security hardening and compliance, which basically strengthens the system's defense and generates documentations for audit requirements. And now we're going to talk about the architecture structure, technical architecture of the whole system. So firstly, there's the network scan, which basically maps devices and ports using Nmap technology. Secondly, it moves to the log analysis, which identifies suspicious logging activities and behavioral patterns. Thirdly is the incident response, which basically blocks malicious IPs automatically and threats to detect. And threats are detected, my bad. And compliance reporting, which basically generates security audits, documentation, and recommendation. Can I say? Sunday.
Okay. I'll be taking the first phase of the project. That will be the network monitoring and intrusion detection. Can you zoom in into the code?
The code, right?
Yes. Okay. Yeah, as for the code, we import various different modules. We import the Nmap, the OS, the RE, the sub-process, and we import date and time. So here we declare a global variable log file as security_scan.log. And here we define log message here. So this just to put the log message into a file, writing it into a file. So here we have the first part here, network monitoring and intrusion detection. So explaining the code, we first define the scan network function. This function helps to scan the network and logs active devices along with their open ports. Nextly, we set the network range. So this 192.168.1.0/24, this represents all IP addresses from 192.168.1.1 all the way to 192.168.1.254. That's basically what this does. And then we initialize the Nmap scanner using scanner equals to nmap.port scanner here. This allows us to perform network scans. And then we print the scan status here. You can see scanning network and the network range. This informs the user the scan has started. And then we scan the network for active devices. So here the SN flag here, the -SN argument, it makes Nmap perform a ping scan to now identify devices that are online without scanning the ports. Okay. And then the for loop, it iterates through all detected hosts. So every host that can be seen. This helps to iterate through of everything. And then the if statement after the for ensures that the host is listed and is confirmed as up or active, anyone. And then we use the scanner.scan to scan for open ports on active devices. So here you can see the arguments -P1 to 1024. This scans ports from ports 1000, port 1 to 1024, which are the most commonly used ports. Scans for the active hosts, and then it extracts the open ports with the second if statement. It detects open TCP ports and then stores them in a list here. You can see it's the open ports variable here. And then we log active devices and open ports. So we use the log message here. You can see we just do some cleaning on the data and then we log it into a file. And then we print the completion message. Network scan completed. That this informs the user that the scan has finished.
Next is log analysis.
Okay, so I'll be taking log analysis. And here, the first thing we need to understand is we need to understand the function behind why log analysis needs to be done. There's a statement that says, if purpose is not known, abuse is inevitable. I just want to read some stats known and backed by data on previously attempts of when data has been breached in companies and its adverse effects. So a 2022 report revealed that 70% of previously breached passwords were still in use, and 64% of users in the companies had more than one password exposed within the past year. Another report shows that since 2004, approximately 9.5 billion passwords have been leaked. And lastly, another one shows that employees reuse the same passwords an average of 13 times, significantly increasing the risk of data breaching. These stats underscore the importance of effective log analysis and threat detection to mitigate risks and associated with password leaks. Because it's all good knowing the automation behind why we need threat detection to mitigate password risks. But if the purpose of knowing it and the risks in which it makes and has to the company is not known, you won't understand the generic function behind the code. So now I'm going to walk through the script that does this log analysis and threat hunting to find leaked passwords. Upon zooming in now, you see created a function here and defined it as detect password leaks. Here, it's going to scan logs and system files for password leaks within all these paths within my list that I created of suspicious _ files. So I've already made a list, and these are the paths it's going to scan. I now have a regular expression of password patterns that I've already created as well in another list. So now, what I'm going to do is we initialize a for loop. So for file name in suspicious files, if the OS path exists, so if the path that I already initially made exists, and if you have access name to read it, it's going to open it and check all the things, all the patterns that I made within my other patterns list. So all these are basically patterns that we have cross-checked, and how when hackers or when threats are happening, these are basic patterns in which you can use to identify passwords that have been leaked in the past. So it's going to compare this with the system and list that I've given it before. So it's going to open that. So for each line, if it notices this pattern within that suspicious file, it's going to give me a message.
Okay.
Warning, possible
Sorry,
password leak.
1 minute. The password patterns you're talking about, is it the password patterns that you put as a variable?
Yes, sir. Password patterns on line 41. So
Okay,
if it
that's
sees
fine.
things like failed in the log file while checking through the log file, if it sees patterns like
Okay,
failed,
just a moment, just take a pause there. The use case you are talking about is actually very valid. Even I find it very hard to manage passwords across different applications because as you grow, you have this application that is, the password is different. You have this application. Now, as a penetration tester, you will have different logins. Now, managing password. Now, maybe we can actually give you guys to actually come up with a password vault solution. What I mean is this. Now, anytime you want to actually, so that you have a tool where you input your password, so you don't need to actually remember it. All that tool does is this. It passes through, it's the one that actually breaks up the password. So the strength of the password is actually not weakened, and you don't need to cram your head in actually remembering the password. And thirdly, you don't repeat the password across different tools. Now, the tool is secure. So anytime you want to log in into the password, you just type in the site. It has it in its database. It brings it out. You put it there. You mentioned a use case of password leakage and all those stuff. Now, I'm trying to actually tell you from the pain point, people find it very hard to manage and remember password across different applications. Hence, they reuse password. That's why you see they are coming up with passwordless. I don't know if you've seen that passwordless application. Now, because they reuse, now, because if you have 15 or 16 applications that you have to actually type in password, and now the ones you remember mostly are the ones you use every day. The ones you use maybe once in 3 months, chances that you would have forgotten it. Do you get it clearly? So if you're developing a solution that you call password vault, all it does is, as you actually are getting to this, it generates a password for you. It keeps it. So anytime you want to log in, you just go there. It brings out the password. You put the password there. Or password manager. Do you get it? So that ensures that passwords are not weak. They meet a particular industry framework standard in terms of the integrity of the password. And you don't lose the time of actually maybe you forget the password. All right, let's continue.
Yes, that's a very good observation. Thank you for that, sir. So upon checking all these patterns, if it sees this in a log file, it's going to print a possible password leak and alert the user. Else, it's going to skip it because these patterns are not in it. It's going to skip that file.
Sorry, let's stay on that password leak. When you say password leak, is it accessing a database or you're just saying a pattern? Because if you say a pattern, it's a little bit it's not now because the guys who hack password, they dump them somewhere. Most of the time,
It's assessing log files and login attempts through these log files, these different log files.
Where are the log files?
In the suspicious files. So we have the auth.log, we have syslog, and we have the bash history. So it's checking patterns within all these log files.
Okay, all right, continue.
Yes. And after doing and carrying out this code and executing this loop, it's going to print password leak detection complete. And this is the basic automation for a password leak detection script that basically checks in real time if passwords are being leaked, and it does this by going through log analysis. So things that were done in this were authentication for log monitoring. So we used regular expressions to create the patterns, and brute force detection. So we identified repeated access attempts from single sources. Unauthorized tracking. So we basically flagged successful logins from unusual locations or time. And credential leak analysis, which also detects potential password exposure in the system logs that feed the files in. So
Okay, so next we have incident response and automation. In this, we considered 4 different things. The first thing we considered was to detect. The second is to analyze. The third is to block, and 4 is to log. To detect is basically extracting the IP addresses associated with failed login attempts. Secondly, to analyze is to count failures per IP to identify potential attacks. And thirdly, to block is to implement IP table rules to block malicious IPs automatically. And then the fourth is to log, which is basically to document all defensive actions for review and compliance. Now, this function basically monitors the logs for repeated failed logins and blocks the attacker's IP using IP tables. Now, what is IP tables? IP tables is a command line firewall utility for Linux that controls incoming and outgoing network traffic using rules. So it allows system administrators to block, allow, or modify network packets based on the IP addresses, ports, and also protocols. Now, how did we achieve this? So if we look at the code, this is the code that we wrote for this. Firstly, we created a function called block suspicious IP because that's what we're trying to do. This is also the third phase in the the system that we're creating. Now we create a variable also.log and equate it to the file also.log so that we can read it and do many other things we want. And then we're also creating a dictionary here, field login IP. So this dictionary is supposed to have the IPs and the number of times an IP was like caught with a failed login attempt. So if we have one IP, the value for the IP would be, let's say it attempted to log into the file once or twice or 3 times, that would be the values, right? So since we're trying to make this
the keys is failed login, while the value is the amount of attempts. Is that what you're saying?
So I didn't hear you.
Dictionary there. So the keys is the failed login, while the values is the amount of attempts of failed login. Is the IP address, Abi? The keys is the IP address, while the values is the amount of time it's tried the failed login frequency.
Yes, so that's it. The keys
right, that's fine. You can continue.
Sorry, the IP address is the key, and then the values are the amount of times that it failed.
The frequency
in this dictionary.
That's fine. That's the same thing we're saying. You can continue.
Okay. So obviously we're trying to make sure that this system can be used in other devices, and we do not know whether they have this other log file or not, or whether they changed the name or whatnot. So we are going to say if the path also.log exists, which is this, auth_log, which is the name of the variable we created for the file. If it exists and is accessible, then we will read the script and do other things, because it's necessary that we know whether it exists or not so that we don't get an error. So saying that it exists, now with open, this line right here is to read the file, right? So upon reading the file, we notice sometimes it's possible that there are non-readable characters in this file. So error equals to ignore is basically to ignore the non-readable characters in the files to avoid the script from crashing. Now we now create a loop. So for line in F, match, read, or search. So this is basically to identify the lines with field password and also identify the IP addresses. And now if match, then IP equal to match.group. So this is basically to impute the IP address and the number of times +1 is basically to like add. If it's called once, it will say 1 time. If it's called twice, it say 2 times. So it's just keep iterating it and adding one to it. So this is to input the IP address that was caught here, found here, and then the number of times that it was found into this dictionary that we have just created. And now this is for where this code right here, this whole block is for blocking the IP address. So what we did was that if the IP has more than 3 login attempts, keep in mind we have the IP address and the amount of times that it tried to log into the system and it failed. So if it has more than 3, greater than 3, that means it will block it. So subprocess.run IP tables. Keep in mind, IP tables is a command line firewall utility for Linux that controls incoming and outgoing network traffic using rules. So what we want to do is block. So that's why we use IP tables here, because we want to block the IP address specifically because it has exceeded the 3 time limit. All right. And I will now say else if the path does not exist. Keep in mind, if the path doesn't exist, it will say skipping the file due to permission restrictions. And then we print IP blocking completed. So that's how we were able to achieve this phase of the system. Next, we have system hardening and compliance reports.
Sorry,
Sunday.
why is Sunday not doing that? I think you've just finished one.
So for the last phase here, we have security hardening and compliance reporting. So what should be expected from this phase here? We have 100% network coverage, which means complete visibility across all connected systems. Also a 24/7 monitoring window, which means continuous protection with no surveillance gaps. And it should also have less than a 5 minutes response time from the detection all the way to automated defensive actions.
Okay.
Could you zoom in?
Can you demonstrate this script? I'm just seeing code. Can you demonstrate this script? All I'm seeing is code. Well, the way you are talking, it looks very interesting. Demonstrate the code first. Let's see. Demonstrate this tool. Let's see it. But it's performing in real time.
So can you hear me?
Yeah, I can hear you.
Okay, so this is the code with everything that we did, and then this is the results.
No, demonstrate it live. Don't tell us
It
results.
takes time, that's why,
Demonstrate it
but I will demonstrate it if you want.
live. Okay.
So now with scanning, it takes some time and it just keeps scanning. So once it's done, it will now input the information into the file that we created for the documentation purpose. But the reason why we just took pictures so that it won't take as much time, because keep in mind, it's using Nmap to scan all the IP addresses ranging from
Sunday Killian, your camera is off. Why?
what?
Okay, your camera was off. Okay, you can continue.
Okay, so to break down the code here, we have a function here, define generate compliance reports. This function generates a security compliance report. And then we define the report file name. So here we have variable compliance reports equal to compliance report.txt. So the report will be saved in a .txt file named compliance reports. So then we use the open function. We open the file for writing. So we open compliance reports in write mode as file. So it opens the text in write mode. If the file already exists, then content will be overwritten. Okay. Then we write the report header. We use file.write function here. It writes a title and then uses equal to here as the separator line and is repeated 60 times. Then we add this timestamp with we use file.write here and we add a timestamp using this generated on with the datetime module here, datetime.now. Then we show the format here, years, month, dates, hours, minutes, and seconds. Then we use it to add to current date and time in the formats. Then we have file.write. Then we have the network scan results. So this adds a section for network scan results. And then we open a log file in read mode as log here. And then we read the content of the log file and then we write them into the compliance report.txt. And then we print the completion message. Compliance report saved as compliance report here. So this is the main function. If name is same as main, we do all 4 of the phases here. We scan the network, we detect password leaks, block suspicious IP, and generate compliance reports. and then we print it as completed once it's done.
Okay. So let's see a real time. Let's see a real time. You are running the script, right?
Yes, that's finished running. So as you can see here, so you can hear me, right?
I can hear you.
Okay, so as you can see here, it says started and it takes some time. It has already finished. So it says network scan complete, password leak test complete, all of this is complete. Now, how do we get this information? The name of the file is we obviously the information that we want is documented into a file that we created. So once it goes to documented into a file, I want to check for the name of the file again. Wait. Once cards. So okay. So it detected the active IP addresses, and then okay, so this is the timestamp for the date and the time, the network scan results. All right, it checks for the active IP address, checks for open ports, and if you look here, you can see other active IPs, right? And it's also supposed to show results for blocked IPs that are trying to like log into get my password and log in, but obviously I don't think anybody's trying to log into mine, so it didn't detect any of that. If not, it would have blocked a specific IP and then said it. So basically that's just how it runs. Like for this one, the IP address is this, and then the port is 587. These are different ports, and that's just a summary of it.
Okay, all right, that's fine. Is that all the presentation?
I'll be concluding everything. So upon implementing this project, we had some challenges that we faced, and we also made some key findings. So based on the stats I read before as well, we will know that the key findings was that automation reduces threat response time by 85% because it is automated, it is happening in real time. Human beings are liable to errors, human beings are liable to make mistakes. But when things are automated, it reduces threat response time by 85%. Log analysis also reveals 40% more threats than network scans alone. So it's all well and good to scan a network, but when you are doing log analysis, you're actually seeing the commands, you're seeing everything that is going on within a system. You're seeing it as it's happening bit by bit in real time. So it reveals 40% more information on threats that you can see. And automated IP blocking prevents 95% of brute force successes because when we have already set a threshold that once a particular IP address tries to get something more than 3 times and it has a failed password, block it. We are already mitigating the risk of breaches and brute force attempts. Now, a couple of the challenges we faced was false positive rates initially exceeded 30%. I don't know, there are some times when something like, let's say for instance, a valid user within a company forgets his own password and he has to guess his own password. He's actually not a brute force attacker, but because he forgot his own password and he tried guessing it more than 3 times, the system, due to our automation, would block him because it's giving signs or it's giving activity that relates to an attacker. So that is a false positive. He's not an attacker, but because it seemed like he was. So these were some of the challenges we faced. Also, detection algorithms required tuning to specific environments. So once again, we had to tune each thing. We had to find a way to make it as adaptable to each environment as possible because there are some certain situations and some certain offices where information is more liable shared across different boards. So we had to find a way to make each script be adaptable to each scenario given. And balancing security with legitimate access needs also proved very, very difficult to this. But it was all part of the challenge and all part of the thinking process of how we would make everything work. Now, going on to the last slide. So, future enhancements and conclusions I would like to suggest is that machine learning for anomaly detection and threat prediction. So, we all know that AI is for tech people like us, AI is most likely going to be one of our very good best friends, and we can implement things with AI that also help with automation that can help with detecting threats beforehand that they happen. Another thing is SIEM integration. So SIEM integration would also really help with connecting enterprise security information and management systems. So it is going to be a very big suggestion to companies to integrate SIEM into their basic workforces and workloads. And cloud security. So cloud security extends protection to cloud-based assets and infrastructures. This doesn't just give software packages or software things, information and protection. This protects the cloud information, things in the cloud as well. And core capabilities is that our automation suite demonstrates significantly secure posture improvements. And one last suggestion that I'd like to give out is, let me give this situation. If I own a security company, a physical security company that creates a system that is made to identify when robbers come into the house, so like if they break a window or if a door is jammed open by force, if I create a system that does that, that system would be brought to shambles if a robber managed to steal a key from the actual house owner, because my system isn't going to detect that an actual house owner opened the door, a robber opened the door. It's going to think it's the actual house owner that opened the door. So I'd also like to suggest workshops and meetings that basically teach employers basic things like password hygiene and knowing the kind of things they're going to do to make their password more hygienic, the lengths, just basic things that can teach them in order to avoid brute force attacks. Also, little simple things like, for instances, some workers might go to a coffee shop and decide to connect to the Wi-Fi at the coffee shop, not knowing that it is a illicit network they are connecting to, and there are people in that network that are sniffing everything that is going on. Simple information like that, by making sure employers are not just leaving the bulk of the script, because the script is going to be fully pointless if somebody just has the access key to your laptop and can just see everything and know the ways behind it. So that would be my future enhancements and conclusions to this whole project.
Okay, all right, that's fine. Can you go back to the breakdown of your script first? Scroll back to the first part of the script, what the script is supposed to be able to do from the presentation. Because you have a place where you have them in one page. Network introduction. No. Come to the, okay. Let's see that part. Okay, network monitoring and intrusion detection, log analysis and threat hunting, incident response and automated defense, security handling, and compliance. Okay, all right, that's fine. Strengthen defense. Okay, all right, that's fine. That's fine. It's more of a SOC project, not penetration testing project. So I think it's a tie. Let's leave it, because you have four of these more to do. Run the first page of your script first. Run the first page of your script. Your own script is more compact. Your own script is more compact. Run the first page of your script. Run the script. I mean, just run the script. Run the script. Let's see how it comes out.
I thought I already did that.
Yeah, let me see again. Let me
I
see
should do it again.
Yeah, do it again. Okay. Can you stop that? Let me just show you something. So this one script here. So it should be like something like this. Are you seeing? This is how commercial script comes out. So you select the option of what you want to do. Do you get it clearly? So you see that this looks more and it shows your name. The tool has a brand name, Recon Hex by so and so. Now, if you come here, let's just choose 14. I'm not here to demonstrate. I just want to show you. So if I enter, let's say I enter Kali, host name, it performs all those tasks you're doing. You understand? So you're talking about enhancement. So that's actually, you understand? So somebody might say, I want to actually just check this. I want to check this. I want to check this. I want to check that. Do you get it clearly? Good. So you see, it actually does everything. However, it has the option to just do only one. Do you get it? So here, I could call it a tie because both of you tried and your stuff is actually, so there's a room for improvement. So I will take another technical course. Then after the technical course, you do this. Then you take penetration testing. You do this. Then after the penetration, that's now make it 2 more. You now do like 5 more. That's 7. Obviously, before you do 7 of this kind of defense, you would have actually come up with something like this that is ready to go into the market. So that's the whole essence. And at that point in time, when we do a job interview for you, you see that you should be able to see your flaws immediately. So do you have any question for me?
No, sir.
I'm sure this particular project has put you up to your toes. And what it does, it actually allows you to be able to measure your capability and align with industry standard. Now, just look here. Along the line, you have to shift up, step up. We're calling it step up. This is what the industry uses. This is Virus Total. So that you start using things that actually, this is API scripting and libraries. This is what people use every day in the office, in real working environment. So you'll be, towards the end, you might be developing something like this that actually integrates into real database. So this is real database of viruses. If you come back here, I was trying to try to sign in. So you can upload viruses here to check in real time if it's malicious. Now there are other malicious how will I put it? Sites. So you'll be exposed that, but after taking penetration testing. So that when you're doing anything, you're speaking pure. This is a very good start, an excellent start. You're speaking very good industry language. So anybody listening to you, you look like a how would I put it? A 6-course meal to the employer, which they will be salivating to hit you up. That means wanting to employ you. So let's stop here. So I will communicate